Welcome back to the deep dive. We are moving pretty quickly through our look at digital capital assets, drawing directly from the research here. So we started with AI as infrastructure, then the digital balance sheet, and last time we met our first worker, the synthetic developer.
And today, we're introducing the second worker asset. This completes the workers section of the balance sheet, and this one is the synthetic researcher.
Okay.
It offers unprecedented leverage. It can read and synthesize hundreds of documents in minutes, just faster than any human team could even dream of. But our mission today isn't just about that speed. It's about mastering the very unique, very high-stakes danger this worker brings to the table.
So if the synthetic developer was the sort of zealous apprentice who never sleeps, the synthetic researcher is the incredibly fast analyst who's also, I guess, prone to telling these really plausible, sophisticated lies.
Exactly. Unintentionally, of course, but that's the problem. This one comes with a huge warning label, and we really need to understand the kind of pressure you're now operating under.
Okay, let's just dive right into the core challenge then, pulled directly from the source material. The AI just synthesized 100 documents into a 2-page brief for your board presentation. It took 90 seconds.
90 seconds.
Somewhere in that brief is a statistic that doesn't exist, a quote that was never said, and a conclusion that contradicts the source it cites. The AI doesn't know which sentences are wrong. It's equally confident about all of them. You have 20 minutes before the meeting. Which sentences do you verify?
In that scenario, it's not a thought experiment. It's the daily reality of this kind of leverage. The AI reads more, it synthesizes faster, it finds connections you would have totally missed.
Right.
But the critical system-defining problem is that it presents mistakes, what we call hallucinations, with the exact same authority it uses for accurate, verifiable information.
Wow, okay, so what you're saying is we can't trust its confidence. We have to treat everything it says, accurate or not, with a baseline level of suspicion.
Yeah.
That really changes how I would approach any report that crosses my desk.
It has to. And to understand how to change your approach, we first have to talk about what the sources call the confidence trap.
Okay.
We tend to think of AI hallucination as a temporary bug, something that will get patched out in the next update. But the research is really clear on this. Hallucination is not a bug. It is a structural feature of how these large language models work.
A feature. Okay, let's unpack that because that distinction, bug versus feature, is, well, it's critical for anyone managing this.
Yeah.
Why is it inherent to how it works?
So think about what an LLM is actually doing. It's generating text by predicting the most statistically likely next word in a sentence.
Right, based on patterns.
Exactly, based purely on the colossal patterns it saw during training. It does not do a database lookup. If you ask it for a fact, it doesn't go find that fact in a table. It constructs a sentence that sounds the most plausible, the most coherent, given the words that came before it.
So if I ask it, what was the growth rate of the European semiconductor market last quarter?
Yeah.
It isn't finding a number in a spreadsheet. It's building a sentence that says the growth rate was X%, where X is just the most statistically likely number to show up in that context.
You've got it. And when that constructed sentence happens to align with reality, we call it accurate. When it doesn't, when it just makes up a plausible sounding but totally false statistic, we call that a hallucination.
But the model itself is using the exact same process.
The exact same process for both. It has no internal censor, no truth flag that differentiates between this is a real fact and this is a pattern that sounds right but has no grounding.
That makes so much sense. So the AI isn't lying to you, because lying implies it knows the truth. It's just confidently wrong.
Yeah.
But if you're the professional relying on that report for a big decision, the result is basically the same as being lied to.
Precisely. Your job is to deal with the result, not worry about the intent.
Okay, let's move from the how to the how often. Let's quantify the risk. What do the hallucination rates actually look like, even for the best models out there?
Well, the sources cite Google's Gemini 2.0/001 as currently the most reliable one you can get. It's tested at a 0.7% hallucination rate on standard benchmarks.
0.7%. That sounds incredibly reassuring, actually.
It does, but you have to think about the scale. If your email spam filter has a 0.7% error rate, who cares? It's an annoyance. But if the system generating your board's multi-million-dollar financial guidance has that error rate, That's a massive
A
risk.
career-ending risk.
Potentially, a 0.7% rate means roughly 1 in every 140 sentences is fabricated. So if your synthetic researcher gives you a 50-paragraph report, that's hundreds of sentences. The odds of at least one hallucination in there are high enough that you just can't ignore it.
And that's the best-case model on general knowledge. I imagine the rates change a lot depending on the topic.
Oh, they absolutely do. It's a huge variation. Researchers looked at legal information, for example, and they found top models had a 6.4% hallucination rate.
Wow.
Compare that to just 0.8% for general knowledge.
That's an 8-fold difference just from shifting to specialized legal text. It shows the model really struggles with nuance and precision.
And that's just legal. The research on medical literature review is, well, it's frankly terrifying. They call it the danger zone. A 2024 study tested models on literature searches where accuracy is everything. GPT-4, which is often seen as top tier, hallucinated 28.6% of medical references.
Wait. Nearly 3 out of every 10 times the paper it cited didn't exist.
Worse, Bard, in the same test, made up references 91.4% of the time.
Oh my God.
And it gets deeper. Citation precision for GPT-4 was only 13.4%. So even when it cited a real journal, the specific details were probably wrong. The unique paper identifiers, the DOIs, were correct only 20% of the time.
And that highlights this problem of the plausible fake. The citation can look perfect. Johnson, M. et al., 2024, AI Governance in Healthcare, Journal of Medical Informatics. The journal's real. The format's right.
But the paper is a ghost. It's not real, and the burden of figuring that out is entirely on you. And that burden is exactly why we need solutions. This level of risk really pushed the industry to invest.
Right. Speaking of solutions, the industry hasn't just stood still on this. The sources mentioned huge investments to solve this exact problem.
Yeah, a staggering amount. Companies invested $12.8 billion between 2023 and 2025 just to reduce hallucinations. It's the #1 technical problem for them. 78% of the top AI labs ranked this in their top 3 priorities. And the most effective technique to come out of that is called retrieval augmented generation, or RAG.
RAC.
Yeah.
So how does that change the architecture to get around this confidence trap?
It basically adds an external check. A pure language model is just using its internal memory. RAG changes the whole workflow. Before it generates an answer, it first retrieves relevant documents from a curated knowledge base.
A set of documents that you, the user, control and have already verified.
Exactly. So it forces the AI to check its homework against a library of known truth before it speaks.
And the results?
They're measurable. When it's implemented right, RAG systems can cut hallucinations by up to 71%. We now have 4 models that are getting those sub 1% rates. This is real progress.
But there's always a but. 0.7% isn't zero. Where does RAG still fail?
RAG fixes the retrieval problem. It makes sure the source is real. It doesn't entirely fix the interpretation problem. The AI can still misinterpret a complex source or quote something out of context or draw a conclusion that, while it's based on a real source, isn't actually supported by it.
So technology reduces the risk. It doesn't eliminate it.
And that means it doesn't eliminate the need for human judgment.
Which, if the tech can't eliminate the risk, fundamentally changes our job. We have to shift from being the researcher to adopting what the framework calls the auditor's mindset.
Your role has completely changed. In the old model, you were the researcher. You searched for sources, read the documents, synthesized everything, built the arguments. You created the final product.
But now the synthetic researcher does all that at a speed I can't match. So where does my value come in?
Your value shifts entirely to quality assurance, to verification. You stop being the knowledge creator and you become the knowledge auditor. Your new job is to review the AI sources, spot check its summaries, verify its synthesis, and audit its arguments.
So it's not a demotion, it's a specialization. I like the journalism analogy from the text. When wire services got faster, journalists didn't become obsolete. They became the fact-checkers and editors. My value is now assurance.
That is the key takeaway. And the governing principle for this whole shift is simple. Autonomy does not mean abandonment. You give the researcher autonomy, but you, the human, retain ultimate responsibility for the conclusions.
The stakes are just enormous. One unverified paragraph could lead to a bad board decision. One hallucinated statistic could lead to real embarrassment. A fabricated quote could damage your reputation for years.
And because you can't manually check 100 documents, you need a system. You need a verification protocol. Let's walk through the 5 techniques for scalable quality control.
Okay, what's the first one for dealing with that high volume?
It's sampling. Statistical quality control. You can't check everything, so you check a random statistically relevant percentage.
So if the AI used 50 sources, I check a random 10% 5 sources. That gives me maybe 10 minutes of focused work to calibrate my confidence in the other 45.
Exactly. And the rule is simple. If that sample is clean, your confidence goes way up. But if you find any errors in that sample, that's your signal to immediately expand your verification.
Okay, technique 2 must be about targeting the most important stuff, right? Spot checking.
This is where you bring your business judgment. You focus on the highest stakes claims. Financial figures driving decisions, legal assertions, attributed quotes that are going to get repeated. Basically, if a claim would make your audience act, you verify it directly.
And then the real foundational work. Technique number 3, source tracing.
The basic question here is just show me where this came from. You follow the citation back to the original document. You find the actual passage. You make sure the AI's summary is accurate and reflects the context. This is how you catch the ghosts.
The made-up citations. Okay, what about testing the logic itself, not just the source? Technique 4.
That's adversarial questions. This is a really powerful move. You test the boundaries of the AI's logic by asking it, what evidence would disprove this conclusion?
Now wait a second. If I'm already short on time, is asking a potentially hallucinating AI that question a good use of my 20 minutes? Couldn't just make up an answer to that too?
But that's the point. A well-grounded conclusion, one based on solid sources, can point to its own limits. It can mention counter-evidence from the documents. A hallucinated conclusion can't. It will start to grasp at straws, give you vague answers. That signals a weak foundation and tells you exactly where to investigate.
I see. It forces the AI to be its own critic.
Yeah.
Okay, and finally, technique number 5, cross-validation.
This is your insurance policy for the big stuff. If you have a mission-critical finding, run the same core query through a different model. If they both agree, your confidence shoots up. If they disagree,
That signals high uncertainty and demands immediate human investigation. This all comes back to the reality we started with. The AI reads 100 documents, but you only have time to verify 5. This is the application of that auditor's mindset. This is the 5-document rule.
Your expertise is no longer in volume, it's in judgment. You have to prioritize your attention based on risk. You verify the 5 documents that would cause the most damage if they were wrong.
So what are the 4 targets for those 5 crucial documents?
First, the highest stakes claims. What assertion, if it's wrong, changes the entire decision the board is about to make? Start there.
Second, decision-driving numbers. Financial figures, growth rates, market sizes. These are so prone to hallucination because they're hard for the model to pattern match accurately.
Third, attributed quotes. These are high visibility. A fabricated quote isn't just an error, it's embarrassing and damaging. You trace the attribution every single time. Never take a quote on faith.
And fourth, the counterintuitive conclusions. If the AI finds something that surprises you, that contradicts what you thought you knew, it gets the highest level of scrutiny. It's either a breakthrough insight or a massive error. You have to find out which before you act.
And you always have to remember the rule of expansion. The 5-document rule is a starting point, not a ceiling. If you find errors, trust goes down and verification has to expand. It's about allocating your attention according to risk.
At the end of the day, this is just professional discipline, not paranoia. If the labs building these models don't trust the unverified output, neither should you.
So 3 key principles to take away from this. First, hallucination is confident error, and detecting it is 100% your responsibility. Second, trust but verify, with a huge emphasis on verify. And third, the AI reads 100, but your value is in using your judgment to verify the 5 that actually matter.
So we've now covered both worker assets on the digital balance sheet, the synthetic developer who builds, and the synthetic researcher who analyzes. But both of them depend entirely on what grounds their work, the data they can access, the systems they use.
And what happens when that underlying infrastructure, the very foundation for all this work, is fundamentally flawed? What happens when the data you're relying on is polluted or proprietary or just inaccessible?
That brings us to the data substrate, the next layer of digital capital. And that's where we will dive in next time.